So hello everyone, my name is Vadym and I'm front-end developer in Evolution, and today I'm going to tell you a story of how we build games in Evolution. Well, short history, the problems we had, the challenges we took, and the lessons we had as well. So how do we build games? First of all, I'm going to tell you who we are. So Evolution is the product company that specializes on providing online casino solutions. And in our portfolio, we have different types of games, including live games, where we have live game studio set up. We take the video stream from the studio, and we stream that to the player, and the player interacts with that. And the RNG games that are actually simulating the same casino experience, but at the same time, all the outcomes of the game are randomly generated. So, how it actually started? Please raise your hand whoever played Flash game in their life. All right. Hitting penguins with a bat, right? The Yetis and stuff. So, back in that time, Flash was the really thing, right? All the cool browser games, or not even games, but browser applications were done using Flash. And, well, we were not an exception. So our first games were built with Flash. But as you know, Flash had several problems. One of them was that it wasn't possible to run it on mobile devices properly. And with the tiny little push from Apple, Flash was no more. So that's how the new HTML5 games era started for us. So on the edge of the transition from the Flash to HTML5, we had just a couple of games that they were run only on desktop browsers. And we thought that, well, it's time to move on and time to pick up some new technology that would allow us to build our games for players who are gonna enjoy that on mobile devices, and at the same time to make our games even more performant. And so at that point, we thought, okay, we need a cool library to render our UI. So we picked React. At that point, it was obvious choice. It was lightweight, it was maintained, it was well documented, and it was evolving. And our games usually very complex on the front-end side. So we have to keep a really big state for the game. So we thought that we need a state management, and guess what we picked? It was quite obvious choice. So overall, it sounded like great duo. Great performance, great scalability, easy debugging, and so on and so forth. And what was the main benefit that we thought, naive, that at some point you can change React to some other rendering library, or Redux to some other state management. And it was okay at that time. Just to give you a little bit of a context what a live game looks like. So here we can see a screenshot from one of our live games from the studio, actually. So the live game concept is next. We have a real live game going on with the real random outcomes. For example, it could be a ball drop on a roulette wheel, or it could be a wheel spin and a hit in some sector on that wheel. Then we have a set of cameras in the studio that cover the main angles of the game. And then that stream from these cameras is being processed, and then it's received by the client application. On the client application, we render some basic UI over that stream. We add some controls, we allow two players to chat, and so on. We somehow allow to interact with the game. So you can place your bets, or you can spot your results. So we started porting our games from Flash to React. Here you can see screenshots from our most popular games. This is Roulette, Blackjack, and Baccarat. And even though these games look different from the studio and setup point of view, they had a lot of similar elements, like the buttons on top of the corner, the chat, the timer, the balance controls or other controls, and the chip stack. So the logical conclusion was to build a library of such components and to reuse them across these games because, well, it's obvious you save on time when creating a new game. So we created a library of these commonly used components. But together with simple representational components, there were also a lot of parts that were repeating from game to game that were crucial and that were well, important for the game. Such parts could be transport creation. We use WebSocket for our games to communicate with the backend because we need a bidirectional connection. And other parts could be like balance handling, which is also repeated from game to game. You have still to receive some balance updates. You have to validate your bets, and etc., etc. So at that point, to start a new game, you still had to build it like Lego, let's say. You still have to create some layout, get some common components, put it everywhere, set up the transport, etc., and only then start building your game on top of that foundation. And it works okay when you have a couple of games, right? But when you want to produce more and more games yearly, you have to somehow change it. So the thing that we thought about was some kind of create React app, but for our game. Something that would speed up the process of developing a new game even more. So developers wouldn't care much of constructing all that common things every time, but they will just run one thing and get everything out of the box. And that's how the abstract game was born. We call that abstract game because, well, you could build actually any game you want on that base. So the main benefit is that you don't need to do all the things. The abstract game will actually create them for you. So you will have everything out of the box. So how would that look like for a game developer? So first, you create some config, because obviously you could need to somehow modify these common UI components. For example, you could want to change theme, or you want to somehow configure layout differently. So you create your config, you import our abstract game creator, you show that config in there, and you get all the things you need, the transport, the other elements, etc. And the most importantly, you get the root element where you can inject your game. And then you basically concentrate on your game, and all the layout is built for you. So now what we have? We have a foundation, a base, core, whatever, abstract game, and the game on top. Now the logical question, what if I am a game developer and I need to somehow interact with that core layout, core abstract game? For example, maybe I need to know if chat is opened or not and somehow represent that in the game or hide something. Maybe I need to know if the video quality dropped, because video component is also provided by the abstract game. Or maybe I want to change the video quality myself. So it's quite simple. Since the whole abstract game base was built using React and Redux, you can use, well, Redux actions to actually trigger something, to send some message to the abstract game, hey, change something, come on. Or you can listen to state of the abstract game. You can subscribe to that from your components, from your game components, or you can subscribe to actions in your game middlewares. And, well, all of that sounds pretty simple and straightforward, and, well, you just call the base, you just create your game on top of that, and then you just somehow interact. But, well, it works when it works well. But there were some actual problems with that approach, as it appeared to be. First of all the games that we were created, they evolved, and they needed actually even more complex configuration, so it was harder to customize it. The second and very big problem was that both the game and the abstract game, they both depended on the same technology stack, on React and Redux. That means that they were tightly coupled on multiple levels, on the technology and also on the code level, because to interact with the abstract game. As I said, you need all that Redux elements. So you had to import all of that to your games. So it was quite a wide thing. The last but not least thing is that testing complexity of game elements became even more complex. It became even harder to test your game elements in scope of the whole abstract game. Since you have all that things imported from the core to your game, you had to mock it, or you had to mock the whole abstract game state to make a proper isolation for your test. So we had to come up with some solution. We called it Abstract Game API. What was the main purpose of it? Abstract Game API was some kind of a proxy between the game and the abstract game. Some kind of technology or framework agnostic proxy that would allow to break that technology dependency, so the abstract game could remain the same, but the games could use actually whatever technologies that they need. So firstly, instead of importing all of that selectors or actions or whatever to every and each of the game, you could use one single instance of the abstract game API instead. But how did we implement that? The abstract game API was actually modular, and every module of the abstract game API corresponded to the abstract game module. So we basically changed the way how we interact with the abstract game, but we keep familiar structure for the games. So instead of getting pop-ups through the selector, you just subscribe to the observable value of that pop-ups module. Instead of dispatching the action, you just call open pop-up action of the pop-ups module. So why did we choose observables? Well, it was simple. By the way, we made our own home-baked solution for observables and used them for to represent the values. Because, well, they are reactive, they are framework agnostic. This is the most important thing for us in this case. And, well, observables are very widely used, so whoever comes and wants to use the abstract game API will be familiar with them. Now the question. So we have the abstract game, which is all built on the React and Redux combo. And we have abstract game API with all observable values exposed and the methods to interact. But how do we keep that observable values in sync with our store? Well, the scheme is actually simple. Abstract game API as a wrapper over the Redux store of our abstract game will just subscribe to the store updates. And in its own turn, on every store update, it will go all over the values and get them updated. So whatever subscriber game has on that value, it will be notified every time when the Redux store is updated. But now the next logical question, how the game can interact with the abstract game elements. Well, for this case, I will use a little bit more complicated scheme. So let's say our game wants to trigger pop-up, and at the same time, game's components want to listen if the pop-up is open or not, and somehow react accordingly. So the game would call open pop-up module of the open pop-up function of the pop-up module of the abstract game API. Abstract game API as a wrapper around abstract game will actually dispatch an action to open the pop-up. Redux store of the abstract game will listen to that action, run that action through the middlewares or whatever, update the store, and then the previous scheme will fire up. So the store subscriber, the abstract game API will be called, it will update the observable value, and then all the observers of this value will be notified, which is cool. So we have bidirectional connection between the game and the abstract game. In theory now, abstract game API could be wrapper over whatever thing we want. We can ditch whole thing, whole Redux, and use whatever else. So this allowed us to be technology agnostic in this case. Now let's see some code of how the code changed when we moved from direct usage of Redux actions and selectors or whatever in our components when we move to the abstract game API. So here we can see very simplified component that will toggle pop-up on click, right? So what do we have here? Well, we import some React Redux hooks, then we import some things from Evo Core, and then what we do? We get pop-ups value from this store using selector, then we have a callback, which will actually either open or close the pop-up based on the value of the, if the pop-ups exist or not. With usage of abstract game API on its own turn, you see that the structure overall, the complexity of that didn't change much, right? We just ditched all the things from React Redux, and instead we used our hooks that I will talk about on the next slide, our hooks instead. So on the line number 6, we just get the pop-ups value. On the next line, we get the open and close pop-up actions from the abstract game API instance, and basically do the same. So here you can see use AG value and use AG hooks, how they are implemented actually. So use AG will basically return the instance of the abstract game API, and use AG value will subscribe to this update of the abstract game API's value and return its value in your React component. So what do we have at this point with the abstract game API? Well, we have tens of games, right? They are produced yearly in batches. In our code base, we have a couple of core packages and tens of game packages that are dependent on these core packages. So we decided to go with the monorepo, first of all, to get rid of the dependency conflicts and the version upgrades, and to make our lives easier in terms of upgrading our core components. Since our code, our live games are pushed to the production every day, and we have tens of thousands of players playing them daily, we can't afford ourselves any kind of regression when we are updating our code base. And you may know how hard it is to introduce any drastic changes in such an environment. You have to keep all your existing and important code alive, while you have to allow some progress to be done in your code base, some movement forward. So what were our future steps actually in this environment? First of all, I showed you our live games, right? But meanwhile, we were developing live games. We also introduced RNG games, and those were built. The main concept of them was that since we don't have video in that game, we built the whole scenery of the game using Babylon.js or Pixie.js libraries. So we built the graphics that will implement our best ideas. And the main thing about these games, the previous approach with the Redux store, storing state in the Redux store, was not much applicable for such games. So we decided to move on with Mobx. And we were actually prepared for that move. With our proxy API, we untied our hands of our developers in terms of picking new technology for new games. So now, on one hand, we have existing core functionality, existing abstract game, and on the other, we have games that will still use our core parts, but now they can pick the technology they actually want. I previously spoke about modularity of our abstract game API. So the next of the future steps would be to make it true modular. For example, if that given RNG game would not need video handling at all because, well, it builds its scene in Babylon.js. It doesn't need video module at all. So at that point, we'll just configure our abstract game API such a way that whole code that will handle video will not be included in the final bundle. And TypeScript will take care of keeping the abstract game instance up to date. So if you want neat video, the abstract game instance won't have it in its interface. So the conclusion, over the years, we built tons of games. We built a huge core chunk that allowed us to make these games even easier. And we made small steps. We made some mistakes on our way, but good choices and later on introduction of the technology agnostic abstract game API allowed us to actually free our game developers, so the core part would live its own life and will be giving what it has to give to the games, and the game developers will actually do whatever they want and implement their crazy ideas how they want. That's it.
Bravo, bravo, bravo. And of course, one of our favorite sponsors, Evolution. We've been together a few times. Does anyone have any questions?
Hi. I know it's hard to quantify. I was just wondering if you know the cost of this refactor and if you were able to put it up against the benefit. Like, do you see an increase in speed now after the refactor in making new games on average? I know that it's hard to quantify and most people don't do this, but if you did it, I'd be interested.
We didn't do that, but as I told, the new games that we were making, the requirement to them increased, meaning on the graphics side. So we couldn't stick to just React and Redux. We had to move on with some new technology. So with this observable abstract game API thingy, we allowed the game developers do what they wanted to do, because you just can't, like, we had huge core part. You just can't throw something out and replace it with some other technology. So we made this API proxy, and we hide it from the game developers.
Any other questions?
So you mentioned, it's not really related to the topic, but you mentioned that you use monorepo to host.
Yeah.
I would imagine would that be to like thousands, probably. I don't know the quantity for sure, but do you store like all the games together with everything related and shared components in one monorepo?
Yeah.
Do you see any drawbacks in that?
Well, there are classical ones like you would have in monorepo. But so far, it was only good way to have it to update everything at the same time. Like, we saw a lot of examples when other companies stored their games in separate packages and their main game framework in other, and they had very difficult times on upgrading that.
Hi, cool presentation, thanks. I'm curious, since you talk about abstracting stuff a lot, I'm curious have you considered using actual game engines to create new games that would work on your platform? Or is it like a front-end approach of using React or any other framework for handling front-end?
Well, we are using Babylon.js to make different games. I know that we have a lot of people working on that. We have Unreal Engine developers as well. So we are working in that direction, and we also had a launch of the game that was run in virtual reality, so you could actually walk around the scene. But because of the type of the game, it wasn't much popular, but still it was there.
So the answer was yes. Thank you. Anyone else? Other questions?
I'm just wondering, what is like the percentage of the ratio between the people who develop the new games on the framework that you build versus the people who maintain the framework?
Mm-hmm.
And do you see it increasing over the years?
The number of developers that are working on core is increasing slower than the number of the game teams, because the goal is to create more and more games, right? So we create more and more game teams. But as for the framework development, it's not increasing that fast. And the percentage, I don't know, maybe 10% of the developers will work on core components, or even 15%.
So everyone, once again, please give a big hand to Vadym.